Now that we've looked at all the different types of factorization, we're going to put them all together and we're going to start to simplify algebraic fractions using factorization. So if we look at the first fraction, we have a numerator and we have a denominator, and we know that in division, which this line is denoting, we can cross cancel. We've looked at that in lots of different videos. But here is the thing. If there are minus signs or plus signs, you may not cancel across that minus or plus sign, because cross-cancelling, cross-multiplication only applies to multiplication and division. So the only way that we can get to that point is to first of all look at our numerator, look at our denominator, and see what forms of factorization can we use to create brackets. So that's an important thing to remember, that factorization creates brackets. So if I look at the top, and I'm not going to go into too much detail of why I'm doing certain things, because I'm assuming at this stage that you've gone through all the videos from episode 1 up to episode 9. If you've done that carefully and absorbed all of those methods, then this should be quite straightforward. So this is basically based on everything that's come before. So if we look at those two terms with a minus sign in between, it's dots, a difference of two squares. So we're going to factorize it into 3x plus 1 times 3x minus 1. And then if we look at the denominator is also two terms with a minus sign in between, so you might be tempted to think of dots, but that's not a perfect square, neither is that, neither is that. So the only thing we can do here is take out a common factor. Common factor of 6 and 2, the highest common factor is 2. X squared and x, the greatest we can take out is x. I'm then left with 6 divided by 2 is 3, and x squared divided by x is x. Now here I took out the entire term, so remember when that happens, 2x divided by 2x is 1. Don't forget to write down that second term. So now if I look at what I've got, everything is now multiplication and division, because it's a bracket times a bracket divided by a term times a bracket. So now I can say that entire bracket will cancel with that entire bracket. Do not be tempted to cancel this x with that x, because then you're cancelling across a plus sign. So what I'm left with is 3x plus 1. In the numerator, I no longer need to write it in a bracket because it's not multiplied by anything, over 2x. Right, let's have a look at another example. At the top here, you should notice that I've got a trinomial, and at the bottom, two terms, a plus sign. Is it a sum of two cubes? No, definitely these things are not perfect cubes. So let's start off with our trinomial, and because this trinomial has got a coefficient greater than 1, that's the one where we need to use the cross method. So factors of 2 will be 2 times 1, and then factors of 6, I can use 3 and 2, and now I'm going to start thinking ahead before I write anything down. If I put the 3 there and the 2 there, I'm already thinking of multiplying down the arms. Then that would give me 4, and that would give me 3, and 4 and 3 can give me my imaginary 1 over there. So I'm not going to waste time by writing it down the wrong way first. I'm going to straight away go into that because I've thought ahead. 2 times 2 is 4, 1 times 3 is 3, double checking, yes, that is correct. So I'm going to read across for my two brackets. So my first bracket's going to say 2m and 3. Remember, I always leave my signs to the end. You don't have to. I just found then I'm not going to make a mistake. And this is going to be 1m, or rather just m and 2. The signs in the brackets are different, and the biggest combination is positive. So my inner combination is 3, my outer combination is 4, so my outer combination gets the positive, and the other one gets a negative. Right, looking at these for a common factor, the highest common factor of the coefficient is 2. M squared, m, the highest I can take out is m. So 2 into 2 goes once, I don't need to write it down. M squared divided by m is m, plus 4 divided by 2 is 2, and I've already taken out the m. So once again, I've created brackets that look the same just by factorizing, and now I can cancel m plus 2. I can always cancel a whole bracket with another whole identical bracket. And I now have 2m minus 3 over 2m. And again, don't be tempted to cancel here because you would be cancelling across a minus sign. So the last one I want to have a look at is quite long, and I don't think I've left myself too much space. So it's x squared bracket x plus 2 minus 2x bracket x plus 2 plus x plus 2 all over x plus 2 bracket x minus 1 all squared. Well, if we look at the denominator has already been factorized. Basically, it's in brackets. What this is really meaning is a bracket of x plus 2 times a bracket of x minus 1 times another bracket of x minus 1. Here we've got a bracket that looks the same as this, but again, you may not cancel because there's minus and plus signs, and in fact, the numerator has 1, 2, 3 terms. So because there are these brackets in each of the terms, and the brackets are the same in each of the terms, we're going to do taking out a common bracket, which we've normally up to now only done with 2 terms, but it can happen in any number of terms. So I think you'll agree that each of these 3 terms has the bracket x plus 2. And then in the other bracket, we're going to write down what's left over from each term. So taking out x plus 2, I'm left with x squared. Taking out x plus 2, I'm left with minus 2x. And then again, be so careful here. Taking out x plus 2, remember there's an imaginary 1 standing in front of that bracket. So I'm left with plus 1. And I'm going to leave my denominator as it is because it's in brackets. And when I'm trying to simplify through factorization, I need to get things into brackets, not multiply them out. At this stage, if you wanted to, you could cancel x plus 2 and x plus 2 because everything here is now multiplication and division. But I'm just going to leave it there to show you that at whatever stage you cancel it, it's fine. Looking at this, I've got a trinomial and descending powers of x. So I'm going to end up with 2 brackets. So x is going to become, x squared is going to become x times x. 1 has only got only got one factor actually, but I can only call it 1 times 1. The signs in the brackets are the same and they're both negative. Again, remember, always bring down to the next step anything that you're not busy working with at the moment, but don't omit it because then that's going to cause a train smash. So I have something very interesting here. I've already said that x plus 2 and x plus 2 could cancel. And I also mentioned just now that x minus 1 all squared means x minus 1 times x minus 1, which is exactly what we've got there. So x minus 1 all squared is actually allowing me to do that. So what am I actually left with? A lot of people will say nothing or 0, but I'm not, because remember what's happening actually is I'm saying x plus 2 goes into itself once, x plus 2 goes into itself once. Everything's cancelling into itself or into each other once. So I'm actually left with 1 times 1 times 1 over 1, and 1 over 1 is equal to 1. So these always fascinate me. Look at that huge thing that we started off with, and as we've processed it through all the rules of algebra and factorization, it's come down to a little old 1.